All right, so if sine 2x equals 2 sine x cos x, what's another way you could write sine 2x cos 2x? With that identity. So how could I use that identity to rewrite sine 2x cos 2x? And I'm not saying replace the sine 2x with that. Instead, I want you to think of, I almost have the right-hand side of this identity, but I don't have a 2 in front. So if I had a 2 in front, right, then this would be equal to sine 4x. Agreed? Can you see that? So then, but I don't have this 2 out in front, so I could take this 2 and put it on that side. And then my integral becomes 1/2 sine 4x dx instead of sine 2x cos 2x. And now we have an integral of the form ax plus b, which you did the other day. How do we do integrals of the form ax plus b? Well, what is the integral of sine? What would I have had to have originally to have an integral of sine? I would have had to have negative cos. I would still have this 2 on the bottom, but what did we have to do when we had an ax inside of, if we had a constant like this, or a coefficient like this 4 inside? Well, we would have to divide by that 4 as well. Because if we did the chain rule of this, we would have a multiplication by 4, so the opposite of that would be dividing by 4. Plus c, where c is any real number. Now, this is fascinating because our answer using this technique, if we compare it to what we got yesterday when we did this question, using our substitution technique, is really different. So one integration gave us sine 2x squared over 4, and our integration gave us, oops, that's the same one. Our integration gave us negative cos 4x plus 8. So it's just interesting that it's so different, and yet both of those are right. Well, they're not equal to each other because we don't know what this plus c is. So it could be that they are equal to each other with different values of that c, but it doesn't make it an identity, which also feels somewhat weird. So this just, in my opinion, terribly fascinating mathematics that doesn't quite make a lot of sense, because we get two answers that are different, that aren't equal to each other per se, but are both right. All right, we are going to finish up these last couple because this is our first example with the substitution technique where things don't look or don't work out well. For example, can you see a function inside of another function? Yes. So the 4x squared plus 1, so one of the things that we look for when we're going to use substitution with integration is there one function inside of another function. And sure enough, there is right there, that 4x squared plus 1. But if we do the derivative of that, the derivative of that is 8x. Does 8x ever appear here? No. And so with substitution, you can still use substitution as long as the derivative is there, and it doesn't even matter what the coefficient is. So the derivative is 8x, but do we have an x somewhere? Yes, we have an x, even though we don't have an 8x. So we start this one off the same way. We say, let u equal that inside function, 4x squared plus 1. Then our derivative will be 8x, and I'll move that dx over to the other side already. But what I want to substitute out is just the x and the dx. I don't have the 8. So we divide the other side by 8, which is the same as multiplying by 1/8. And then that is what will replace the green in our function. So now the yellow is going to get replaced by u, and the green is going to get replaced by 1/8 du. So what does that look like? Well, we would still have e to the u, and instead of the x dx, we have 1/8 du, which is the same as 1/8 e to the u du. So how do we integrate e to the u? Well, the 1/8 is just a coefficient. It's going to stay there. We're going to get 1/8 e to the u plus c. And so now we can substitute back. And one thing that you might do while integrating, whether it's on a quiz or a test or your final exam, is sometimes you just want to feel like, did I get that right? How do you check if you got it right? Take the derivative. So if you did take the derivative of this and you simplified it, sure enough, that 8 would go away and cancel out, and it would match up perfectly with what you started with. So I'd like you to try this one, because it's another one where the derivative is there, but the numbers don't match up. I want you to see if you can see what's the inside function. You're probably going to have to rewrite that square root as the power of a half or power of negative a half. So first thing to check, did you get your substitution right? And then simplifying it. Yes. So if u is equal to 5 minus 2x to the 4, and I do the derivative, I'm going to get a negative 8x cubed. Of course, if I highlight my function here, this is my inside function, which I made u. I need to get rid of that. So when I took the derivative of u, I got an extra 8 here. It's once I divide by 8, or negative 8 in this case, that I get that x cubed dx by itself. So I'm looking for how do I rearrange things so I can substitute that part out, and that's where the extra 8 comes in. So take a look at this last question, read it through, and I find that one of the things that has helped me in math, especially when going into quizzes or tests, is when you see a question, you give it a label. You kind of describe what kind of question it is. So when you read this one, what kind of question is this? Do you have a label for that? It's one where you have to find C, solving for C question. So we did these a while back where you integrated, but since you have another point, you can actually solve for C. So one of the things is getting good at just recognizing questions. So if I want to find f of x, I'm going to have to integrate. So I'm going to need to integrate 8x over 4x squared plus 1 dx. Do I see an inside function and do I see an outside function? This function is inside a 1 over x graph. And if I let u equal 8x squared plus 1, then du, 4x squared plus 1, I love that little eraser. I should make more mistakes because using that little eraser makes me happy every time I get to erase with it. I don't know why. Anyways, sorry. You just get 8x dx. So our integral becomes 1 over u du. And what is the integral of 1 over u? Natural log. Oh. Things were looking okay, and then the natural log had to show up. So now what do we have to do to find c? This is our function f of x, right? Because f of x would be the integral of the derivative. What do we know about f of x? When you plug in 0, you get 4. Oh, but before I get too far, we still have a u here. We don't have an x, right? So I'm going to have to resubstitute back in that u was equal to 4x squared plus 1 plus c. And now when x is 0, y is 4. What is the natural log of 1? E to what power is 1? It's 0. So then you get c is equal to 4. So we can write out our final equation is equal to the natural log of 4x squared plus 1 plus 4.